car is travelling along a straight horizontal road with velocity 32.5 meters per second. The driver applies the brakes and the car decelerates at 8 minus 0.6 t meters per second, where t is the time which has elapsed since the brakes were first applied. Show that while the car is decelerating, its velocity is this. Find the time taken to bring the car to rest. Show that the distance travelled while the car is decelerating is 75 meters. So here's the question then. We know the acceleration, so here the acceleration, which is the rate of change of velocity with respect to time, is equal to dv dt minus, because it's decelerating, this 8 minus 0.6 t. Okay, so separating the variables and integrating, so it's minus dv, that's the dv, move the dt up, 8 minus 0.6 t times dt, so minus v here is equal to, integrate this with respect to t, 8t, minus 0.6 t squared over 2, so that'll be 0.3 t squared, because the 2 will cancel. So that plus a constant of integration. So v equals 0, t equals 0 then, gives, it's not quite 0, is it? At time is 0, 0, v is equal to 32.5. So let's put that in, 32.5 here. So minus 32.5 is equal to, t equals 0 means these will be 0 plus k. So that tells us what k is, minus 32.5. So we can write down what v equals. Run a minus through all these, so v equals minus k, I'll put that first, minus this is 32.5, minus this is minus 8t, minus this is plus 0.3 t squared. And this is what we needed to show. That's the velocity then. Find the time to stop, part 2. Time to stop. So when does v equal 0 give? That's when it stops. So we get this equal to 0, 0.3 t squared minus 8t plus 32.5 equals 0. So t will equal then minus b, minus 8 is plus 8, plus or minus the square root of b squared minus 8 squared is 64, minus 4 times a, 0.3, times c, which is 32.5. Okay, all over 2a, so that's 2 lots of 0.3. So t will equal then, it will equal, so I'm just going to work out this square root. So 64 minus 4 times 0.3 times 32.5, 25, so it's a 5, square root that is 5, over 0.6, which equals 3 over 0.6, or 13 over 0.6. Okay, so we'll take this, the first time must be the answer, the first value. Is the answer. So t is equal to 0.6 into 3 goes 5 times. 5 seconds. That's what makes sense, and then basically it stops, doesn't it? Because it's a braking force. So the time to stop is 5 seconds. Show the braking distance is 75 meters. So part 3. So what did we get? It starts with 32.5. Its final speed is 0, so this was the initial speed, which we can label as u. The acceleration, which we said was, what was it? Oh, we didn't work out the acceleration. Oh, yes, we did. 8 minus 0.6 t. 8 minus 0.6 t. Okay. The distance. Oh, we've got our velocity. We're going to have to, because it's not uniform constant acceleration, is it? So we need to use v and get the distance from that. So from the velocity time graph. So v is equal to 32.5 minus 8t plus 0.3 t squared. So distance will be the area under the curve, the velocity time graph, between the time when it started to brake to when it stopped, 0 to 5 of this v minus 8t plus 0.3 t squared dt. There's the area under the curve of the velocity time graph between 0 and 5. It's always positive, v is always positive, so this is fine, because it goes from a positive acceleration down to 0, doesn't it, at 5. Positive velocity down to 0 at 5, so we get 32.5 t minus 8t squared over 2, which is 4t squared, plus t cubed over 3, so that would be 0.1 t cubed, won't it? Between 5 and 0. So that's equal to 5 of these, 5 of these, and 5 of these. So we'll put it in the calculator. 32.5 times 5 minus 4 times 5 squared plus 0.1 times 5 to the power 3 equals 75. There we go, and I think that's the I think that's what we were actually asked to show. Yeah, show the braking distance is 75 meters. So you could actually write down the values before you do the final calculation in the calculator to show you the method, get some method marks.